All right, kiddos. Today we are going to take what we've learned related to the nature of light and the electromagnetic spectrum and relate it to, I hope, the Bohr model of the atom. Once again, you might recall that Bohr wanted to understand the behavior of the electrons as they orbited the nucleus of the atom. What element did Bohr study to help him understand this arrangement of electrons in the atom? Well, Bohr studied the hydrogen atom. Now you might say, well, why did Bohr pick hydrogen to understand the behavior of electrons as they orbited the nucleus of an atom? Well, pretty simple. Hydrogen only has one electron. So Bohr supposed if he could understand the movement of one electron for hydrogen as it orbited the nucleus of an atom, he could extrapolate his understanding to an atom that had more than one electron, or many more than one electrons. And this is what Bohr came up with. Here is the nucleus of the atom that Rutherford discovered. Remember, it's positively charged, it's really tiny. Bohr learned that the electron orbits the nucleus a certain distance away from the nucleus. He called this an energy level. So the energy level that was closest to the nucleus turned out to be called the first energy level. But he also learned there's more than one energy level. The second energy level away from the nucleus he called, or we ended up calling it, the second energy level. And there's a third energy level, and so on. We'll stop at 4 kiddos. And Bohr supposed this. Let's suppose there's an electron on the first energy level, and we excite that electron by either passing electricity through the vapor phase of that element, or maybe using a flame to get that electron excited. And that electron can move up to the second or the third, or let's move it all the way up to the fourth energy level. So now it has more energy than it did a moment ago. Electrons are sort of like you and me. They don't like to expend a lot of energy if they don't need to. So this electron in the fourth energy level is not going to stay there. Eventually it's going to fall back down to the first energy level, but it might not do it in one step. It might drop down from the fourth to the third energy level, or it might drop down from the fourth to the second, or it might drop down from the fourth all the way to the first. In each case, that electron would give off the energy required to move up that energy level. So for instance, if the electron moved from the fourth energy level down to the third, it would give off energy. Now watch how I draw the energy being given off. I'm going to draw it as a wave. In fact, I'm making this a pretty big wavelength. If the wavelength is big, isn't that a small amount of energy that's being given off? What about if it dropped from the fourth energy level all the way down to the first? I'm going to draw that wave a little bit different because that electron is going to give off energy equal to the amount of energy that it was required to pull it all the way up to the fourth. But this time I'm going to draw that wave really close, make it a much, much smaller wavelength. I know that's not a great picture of a wave, but the wavelength here, the distance between waves, is much smaller. So it would have higher energy. So when Bohr looked at these excited atoms, he saw different colors being emitted. For instance, this small jump might be red light. Remember, red light has a larger wavelength, a smaller energy. This big jump from the fourth down to the first, this might be violet light because the energy drop is so big. Remember, big energy equals high frequency. What about a drop from the fourth down to the second? Yeah, it might be somewhere in between. Don't you agree? Maybe it's a green-colored light or something like that. And the wavelength would be smaller than a fourth to the third drop. It'd be smaller than this drop here, but it would be bigger than a drop from the fourth down to the first. So somewhere in between the two maybe. we give off a different colored light. So Bohr, knowing and understanding the nature of light and how we could determine energy based upon the color of light being given off, he was able to determine the amount of energy that was required for the electron to move from the first to the second, or to the third, or to the fourth, and so on. So he determined that electrons have specific energy levels. He discovered the energy levels of electrons. Now, you really need to see this to understand it. So there are 3 different videos I want you to watch. They're demonstration videos, and you will see the emission spectral lines for the hydrogen atom, for the mercury atom, and for the neon atom. And then when we come back, I'm going to show you the spectral lines for helium, and you will notice that they will each have different sets of colored lines depending upon the energy levels of the electrons in those different atoms. So, in conclusion for this video, Bohr discovered the energy levels of electrons. He was able to do so by understanding the nature of light. And if he knew the color of light, essentially he could figure out the energy of that light and the energy levels of the electrons that orbited the hydrogen atom. He then extrapolated that to other elements that have more than one electron. Okay? Make sure you watch the demonstration videos before you come back for hydrogen, hydrogen, mercury, and neon. Okay? We'll see you soon. Bye-bye.